And we're ready. Kick it off. Brandon?
All right. Hello, everyone. I'm Brandon. I've been working with Andy on bringing Arkime to Kubernetes. So I have a few slides. There's not many. But whenever I started working this, I think Andy and I were brainstorming on what the use cases were. So these are the kind of the two that I've come up with. And then hopefully folks here or on Slack can reach out and say if we missed any or what we should be catering Arkime and Kubernetes for. The first one is orchestration. So this use case is predominantly what I've been focusing on the first iteration of bringing Arkime to Kubernetes. And so this is like a way of installing Arkime with Kubernetes. So you may be using Kubernetes for other things, or you may want to only use Kubernetes for installing Arkime to like create this cluster and have everything join nice and easily, or replacing things like Ansible that you may have previously used. I think that's the predominant use case of this. The other one is if you're heavily a Kubernetes user and you want to actually monitor pod traffic, and this is probably a slightly different way of deploying it, but one that I think we could be flexible to if people are interested in that approach as well. There's probably some Arkime features too that could be added to make that use case a little more interesting, like potentially a controller that looks at the pod IPs and matches it to the pod IDs or pod names or something in Arkime itself. All right, so here's like a little diagram. This isn't really revolutionary here. This is basically just how Arkime works, but with some annotated like what maps in Kubernetes. So we've created a Helm chart for Arkime to try to make this process pretty simple. The Helm chart basically consists of this ingress that maps the three services, so Arkime Central Viewer, Context, and Wise here. And then each of those services are deployed as a Kubernetes deployment with a service in front of it. And then on the capture side, there's a sensor daemon set that uses PVCs that runs viewer and capture in the same pod and is configurable to either run with host networking or not in host networking. A lot of this stuff is actually configurable. So you can actually turn off, if you're using the S3 plugin, you can also turn off a viewer in the sensor daemon set pod. I don't think I'm missing anything there. So that's pretty much it there. All right, so what we did, we created a Helm chart. There's a lot of debates on whether Helm charts are good or flexible enough, or if they make you want to like pull your hair out to manage. So we'll see if that works or not, but pretty much everything is configurable in this Helm chart. Hopefully that's good, but it makes the things that you can configure a little bit more complicated. So some things that you may want to do with this is like a node selector for the sensor daemon set. If you only want to capture on certain nodes in your cluster, you can configure all of that stuff if you need node affinities. All that stuff is configurable. And then I was talking about this before in the host networking. We default to host networking because I think it's the easiest way. But you can also use the Multis CNI or any Multis CNI where you can pull in multiple network interfaces into your pod, so you don't have to use host networking if you do things that way. We can support that as well. I haven't tested it. I think it should work, but probably be good to test that and see if people are interested in that path. All right, and after this, I'll do a demo, which I know is in reverse order here, but in the future, things that I would like to do is ship a default network policy just to provide a lot of the out-of-box security stuff, since this is a security component. Internal component certs is probably more near term. So today, the Helm chart ships with cert manager resources, or basically just annotations you can add to where it works with cert manager. So you can get a public cert for the ingress, but currently the internal components of Central Viewer, Wise, and Context, they don't have internal PKI set up. So that's something I probably do in the near term. And then a lot of different docs for different use cases. So I've tested this locally using Kind, which is Kubernetes and Docker. I think Andy used Microcube a bit. I'm not sure if we really tested on Microcube or not. And then I've tested on EKS as well. And then something that I'd like feedback on in this meeting is like if folks think a Helm chart is the right way, or if there's enough functionality, if like an operator would be a better choice than the Helm chart. All right, now we'll go to a demo. That's all the little slides that I had. Actually, let's look at the chart first. All right, hold on one second. All right, let's do this. All right, so in the PR, or there is a PR up. Let me show you the PR first, if you haven't seen this. This is the PR. You can go here, Arkime Helm chart for Kubernetes, and look at the actual code. Andy and I have been pushing stuff up here as we work on stuff. All right, so here's the chart directory, or the Helm directory here. Let me go up here. And this is the README. So the README provides kind of a full walkthrough of this. So it starts you off with no Kubernetes cluster. If you already have one, you can skip that step. And this walks you through a local installation. So this is using Kind. But easy, just skip the steps that you already have stuff, infrastructure up for. And then once we get down here, the Arkime Helm chart install, if you want default values, is pretty straightforward. You basically need to export the credentials for your OpenSearch or Elasticsearch cluster, store it in a Kubernetes secret here, and then we'll skip down. You can configure the password secret, the server secret as kind of optional steps here. If not, it's going to default to things. And then here is where we actually install the chart here. So if you pull this down and Helm upgrade install Arkime, you'll get the default values chart there, which we'll look at in a second. And then to configure things in Arkime, what I've been doing is just execing, like for creating the internal user stuff in the internal user database. I've just been execing into the central viewer and then executing the shell scripts that Arkime provides. That tends to work well. If you want to do something more interesting, you could stand up another pod with the Arkime container if you don't want to do this execing in the central viewer. But this works pretty well. Yeah, and then it walks you through kind of port forwarding to the ingress, or the service here in this case, so you can check to see if anything's working, or you can go ahead and do the ingress controller. And Kind, it's a little weird because you have to port forward the ingress, but if you're deploying this on AWS or some other real Kubernetes cluster and you have real ingress controller, it's pretty easy to test that as well. All right, let's look at what I actually have set up here. So clear. All right, so I went ahead and did the Helm upgrade. So this is just an EKS cluster that I stood up. I went ahead and did the Helm upgrade install so that we didn't have to wait for the load balancer to come up. So whenever you do the Helm upgrade, you see the pods here. Actually, let's look at the deployments because that'll be a better way of looking at it here. So it creates the Arkime namespace. And then we get the Arkime central viewer here. There's 2 pods for each of the deployments, Arkime context and Wise. And then I also have external DNS installed and metric server, which doesn't matter. Yeah, and there's also the ingress controllers on here. This is an EKS auto mode cluster, so the ingress controllers are built in, and node autoscaling is built in and all that stuff. So I don't have any of that stuff installed, but all that works here. So if you jump to the pod view here, now actually look at the daemon set. This is the sensor daemon set. So if we jump into the YAML here, you can kind of see what it is. It's just 2 containers, like I was saying, the capture container, using the Docker stuff that Andy recently put in, and then also the viewer container is down here. There's some permissions dropping, but I think we can probably do a little bit better on what we're doing with the permissions. So that's probably an area that we need to work on a little bit. So in terms of, like I said, I use most of the default values for this, but in terms of configuration, I can back out into the values.yaml here. And so like I was saying, it's a lot of configuration here because I made everything, or most things that I thought should be configurable. I tried to break it up into sections that make sense, and it's kind of default to most Helm charts. The top part is kind of stuff that doesn't fit with anything else. These are more like global things. So the ingress configuration was a little bit more pick and choose what I thought was useful here, and then some commented out stuff. Like this would be, if you're running an AWS with the AWS load balancer controller, you probably want to take this stuff. If you want to use external DNS, you probably want to use this stuff. But if you're using Nginx, then it's sufficient to not use any annotations really. The config map, this is the Arkime, the config.ini file. You can specify your configuration here, or you can use the environment variables. This environment variables block here goes to all containers all containers deployed, so it'll go to context-wise, central viewer, and the sensor daemon sets there. So it's a nice way to kind of configure everything here. All right, let's jump down, and then I'll show you kind of I'm not going to go through all this configuration, but I'll show you the way it's kind of made or structured here. This is some capture volumes, and then here we get into the actual pods or deployments or whatever, like the unit of deployment that we're at. So this bootstrap is a job that bootstraps the database. So it runs Arkime init. And then you have the stuff that I went through before. So this is the sensor daemon set, and you have all the stuff you can configure here for the sensor daemon set. So you can override pretty much everything here. And you also have environment specific stuff for sensors. So the global environments are merged into this environment set there. All right, and then we have central viewer. So that's just the central viewer deployment. Same stuff as the sensor stuff. It's just got all the configurations for normal deployment. And then we have context, and then we have our WISE block. So I know it's a lot, but it's broken up kind of nicely, and it's a lot of the same stuff, just over and over. All right, so let's look at our cluster again. Go to pods here. Actually, let's go to ingress. All right, so ingress, we have this load balancer all set up here. So I'll try to go to it real quick. Should have like prepared more and actually had my domain. Hold on one sec. All right, let me switch this real quick. In the meantime, anyone have questions before I pull this up? All right, I found it. Oh no, the button went away again.
The share screen.
There we go. I just have to hit leave call, and then it pops up beside the emoji. As intended, I suppose. All right. All right. Just put that there. All right. So Arkime, it just auto-filled for me. Oh, it's because I'm in the wrong thing. Okay, here we go. Here it is. All right. Super secret credentials. All right, yeah. So now we have Arkime set up there. This is the first time I've been to it on this install, so I'm glad it worked. But the ingress controller insert manager, got it real credentials here. You can see I use cert manager with ACM, so it's a cert from Amazon. But it's valid cert, public valid cert. You can use the issuer setup is. Let's go here real quick. So if you look at the issuer, or I forget what the resource is called. Cert issuer. No. All right. I forget what that's called, but it's fine. We'll come back to that later. So here's a central viewer. So we can do our little test here because we had problems with this before. But the PCAP comes up here. All this stuff works great. And then if you want to get to WISE and context, it's all, you can just use /WISE. And we'll get WISE here. And then /context. Context. There we go. And then we get context here. So they're all three deployed here with valid certs. Get back here. All right, cool. And I'm not the best person to demo actual Arkime stuff, so I'm pretty much done with this. Questions, comments? What did we get wrong?
you talked about using Multis. What are your
Yeah.
plans for that? Just purely for pulling traffic from the containers themselves, or are you wanting to eventually bind one of those interfaces to a host interface?
Yeah, I think I guess it depends on what you want or what people want. I think we had talked in Slack where you were saying you basically just pull the host interface or one of the host interfaces into the pod, right? Which I think makes sense because then you don't need host networking on the pod. You can keep things a little bit more secure or more managed in that way.
Yeah, that would definitely be the golden goose egg. Obviously, there's a lot of issues with trying to get that working, though.
Well, yeah, I don't know if it's too bad. I think the configuration would actually work now because with Multis, all you need is a annotation on the daemon set, and then it's already configurable to make it not a host networking daemon set. I think that's pretty much all you need, and then you're just configuring the daemon set to capture on whatever number the Multis interface is that you've bound to your pod. I think it would work now, but I haven't tested it, so I might be missing something in the workflow there.
I'll definitely have to try that. It'd be awesome.
Yeah, it'd be great if you can test it and let us know if it works.
As far as your
sorry,
go ahead. Seth, go ahead.
No, you're on a roll. I'll go.
Oh, I was going to say, I don't know how it works with host-based networking, but as far as your internal certificates between your viewers, what a lot of people do is usually a service mesh, and that way they have Istio or whoever they want to use handle the certificates for internal traffic, and that would definitely be preferable for more people instead of dealing with an internal PKI. But again, no idea how that works with a host-based networking. But if the Multis thing would work, that might fix that issue.
Yeah, the service mesh is interesting. I didn't know how widely service meshes would actually you'd want to use just because it's another step. I think it's something we could probably support as literally just giving you the ability to add another container to the pod, or I guess if you run some of them, they'd use like a mutating webhook and just inject themselves.
They do now. They used to sidecard, but now they do that. Okay. I don't mean that it needs to be added to the Helm chart by any means. That's definitely something that needs to be done by whoever's setting it up. That's like trying to set up the CNI or the CSI for everybody. It's just unreasonable.
Right. Yeah, and there is. I just want to make it mainly where the values are good defaults, but you're able to kind of modify things to get a service mesh potentially to work or something else. So right now I have a self-defined CA as configurable, so you can turn it off. I think like if you only want PKI, this is probably like pretty good because for you as the person installing it, the Helm chart, everything kind of happens automatically because this will create a self-signed certificate authority and an issuer for that certificate authority, and then everything every component can just basically make a CSR, and it'll automatically be signed by Cert Manager. And then you can install, I think it's Trust Manager or something that will distribute around the chain of trust with all the components and keep it in sync for you.
Okay.
So it might keep it as like depending on the usage, I guess, keep it as an optional thing and then see how many people actually want to use service mesh versus something else. The service mesh is nice too, is if you use service mesh, you probably want Arkime to run over HTTP or something since your service mesh is already taking care of the TLS connections.
Anyways. That's kind of what I was going into next is whether or not you have the ability to just turn off encryption in total. Because another thing too is if they have just a few nodes sitting in the same data center off of the same switch, they may not even want encryption except for the ingress. controller itself, which people usually either use Cert Manager or whatever, load up their own TLS secret and point it to that.
Yeah, I don't even know how you'd turn. Like, is there a configuration, Andy, to turn off TLS if you didn't want it? I know you'd yell in the logs and stuff, but
Yeah, I mean, you have to configure that you want TLS turned on. So I think right now, actually, it is turned off for.
is it?
Yeah,
Oh, okay. Maybe you're right. Okay, all right.
we always use it when we're talking to OpenSearch or Elasticsearch, but
Right, but that's on the
Which one?
Elasticsearch specifically, right?
right.
And I run OpenSearch in Kubernetes as well, and so I use an ingress controller to manage the certificate for that as well. So
Hmm.
it makes it a lot easier for everybody as far as how they handle it.
Okay, so you ingress your Elasticsearch. So for internal communication, you go through the ingress, or do you go through the service?
Well, currently they're not sitting on the same Kubernetes nodes, so I have two separate clusters, so they have to go through the ingress controllers. But
right.
if they
Okay,
were all
I
on the
see.
same one, no, they wouldn't need to.
Gotcha. Okay.
Actually, that's not true, because I believe OpenSearch and Elasticsearch, it's nigh impossible to turn off the requirement for encryption, if I remember right. I'd have to double check, but I know for my deployments, I have to basically use the ingress controller to trust the backend service, which is also encrypted.
You can turn off encryption if you want to for OpenSearch or Elasticsearch. It's just a config variable. It's not that I recommend you do. I personally, tell me what you think, Taylor. I don't think we should worry in our Helm stuff about OpenSearch, Elasticsearch. I mean, you just get to set an URL, and however you want to set it up. That's
I would
how it is.
completely agree, especially considering if you go to Elasticsearch or OpenSearch, the first thing you look up for Kubernetes, they're like, here's a Helm chart to install the operator. Here's the steps on how you can deploy it, right? That's, I mean, if you wanted like a dev box or something down the line, that might be different, but that's a lot of extra things a lot of extra moving pieces where you don't really need to be dealing with it.
Right. Okay, but so let me just make sure I understand. You're saying we should come up with a couple different ways of allowing the viewer nodes to talk to each other when it comes to certs, and make that configurable.
What I was saying is make it easy and just have them default to non-encrypted. If people want them encrypted, they can go through the efforts of, I don't see how it wouldn't be super easy to just go ahead and change the configuration and point it to a secret, have the secrets mounted to each daemon set for certificate. If people wanted to go through that convoluted step, or they could go through a service mesh and handle it that way. It's just, I would just put a disclaimer on there. Hey, this is not encrypt traffic between the viewers. So if you're, have distributed systems through multiple physical sites, you might want to look into either setting up a service mesh or coming up with some form of, setting up encryption.
I guess my response would be, and maybe Seth could chime in, is there will be people who have to have encryption between nodes, and we should at least have a document about how to do it super easily if we don't support it directly.
You could just go ahead and do it's probably not ideal, but if people are just looking for a checkbox to tick, you could just do a single cert for all the viewer nodes and just do a really quick, just really quickly set up in the Helm chart to say, hey, use certificates, yes, no, whatever, right? And then at that point, you can go in and to each of the daemon sets and bind the secret for the TLS and make that configuration change. So at that point, they would have to, make a change in the values.yaml and then just the configuration, right? So either pass it through the variables or pass it through the configuration in the values.yaml.
Yeah, I mean, we could do like a super simple setup, but it also may not be what people would expect, I guess, because if we did that, there might be a point where if the cert expires or something, they'd have to deal with it, or we'd have to do something to deal with it. Or we could do long-term certs that are 100-year expirations or something, but people probably don't want that. As
Certificates are easy to replace in Kubernetes if you're pointing them to an existing secret. You just paste over a new certificate on it. The only issue I could see is the trusted CA. But beyond that,
right, it's just another
if they want
step people have to do. That's why, like, the service mesh, a guide for service mesh sounds like probably the way to go.
I would agree. Just, you can easily break your Kubernetes cluster if you don't set up service mesh right.
Right.
So it's just up to you guys on like how much work you want to do on the Helm charter and how much flexibility you want to give to the people. But I've definitely been leaning towards the, keep it simple and then expand from there.
Yeah.
Okay, hey, Seth, did you have some questions or comments?
Yes, if I can figure out how to unmute. So the one of the things that I've dealt with that's been a pain in not really related to this domain, but just kind of like in general is it seems like when I'm on different different Kubernetes environments, whether it's like EKS or like K3s locally on-prem or like Azure or whatever, is like dealing with the backing storage for stuff, like particularly if you get into issues where it's like, oh, I need like read write many across these different pods and things like that. So I assume, I mean, with Arkime, everything storage wise, on the one hand, like you've got the indexing and stuff that it just lives in OpenSearch and Elasticsearch, and you just kind of throw it over the wall to them. On the PCAP side, like, does the storage for each PCAP, does each like capture pod or whatever or service? I'm still learning a lot of the terminology and stuff, so like a lot of it's kind of fuzzy for me what things actually mean. But like, does the underlying data storage for each capture thing, is it just like specific to that, or how do you guys manage that, the kind of like the backing storage for PCAP?
Yeah, so there's a couple ways that you can configure it currently. So the first one, the easiest one to conceptualize, is the host volume. So you can just map the host volume to your sensor pod, and then everything gets stored locally, and it stays there, right? Because the central viewer will just query it and download it when it needs it. So everything's local. If the node goes away, your PCAP goes away as well. The other way, which I was using actually in this demo for EKS, is persistent volume backed by EBS. And so that whenever a sensor pod comes up, persistent volume claims created, and that triggers an EBS volume creation for that pod. So that's nice. If your node goes away, you keep your PCAP, and you can do whatever you want with that afterwards. And then the other way, there's actually a couple other ways you can use a persistent volume with ephemeral storage. So that would just be similar to the host one, but it's kind of it's a little bit more flexible than the host one. And then you could just remove viewer if you're on the cloud and use the S3 plugin, and then your PCAP would be stored in S3, and you don't have to deal with storage at all.
And it's S3 compatible, so it supports mini IO, supports B2. I can't remember if Azure works, but I think Google works.
Okay, cool. Yeah, that's interesting. I took some notes there. I'll have to go look some things up. Like we've done some stuff with some of those. We've also just done like NFS, like in EKS, for example, or locally, like you can create NFS and then point the volumes at that. But I think that isn't as flexible. So yeah. Anyway, yeah, thank you.
Yeah, I mean, what someone's posted was that they are doing mini IO even on local, just because it's central instead of something like NFS.
Yeah.
One of the things that I think we will have to look at if this becomes popular is with those different types of volumes, the sensor could still go away and never come back. But if the storage is persistent, then like the central viewer, it would be nice to figure out a way if a central viewer could mount, these
binding.
Yeah, these homeless volumes. I don't know.
Yeah.
Well, you can make a new PCAP variation that has the node name tagged into it.
Yeah.
Or a dummy file. I don't know.
No, you actually can already do that. I mean, you can set up the directory template, and that might be what you're doing, Seth, for your NFS volume, where you can already specify when it writes the PCAP how it writes it out, so it has the node name as a directory.
Yeah, I'll have to look, and I don't remember exactly what we're doing in that regard. I'll have to go look at it. But that's an interesting idea.
But so then what we would do is we make central viewer smart enough that it could first check to see if it has it locally, and if it doesn't, then go reach out some kind of hierarchy. But definitely looking for feedback from you folks, because I've been dragged kicking and screaming into this for years, and so now we're doing it. So make sure you tell us what you want.
So on the configuration, are you creating a central configuration in Kubernetes and pointing all of the daemon sets to it?
So that's one way, which I don't think we've actually tried yet, but that was the original way. The other way is just the environment variables. So the environment variables just get propagated to all the containers. So they're kind of independent, but you configure them all in one place and they go out to everywhere else.
Okay.
Yeah, so the next version of Arkime 5.6.1, is going to have even more environment variable features where, every time, as the case always is, when you use something to do it, you find what's missing. And so we found a bunch of things that are missing, and now everything, all the config is with the environment variables. So even like weird sections can be now environment variables if you want. You can still do the config file, but you don't have to. The one exception I think will be WISE, and Elise is, even though she's hiding her face, is vomiting right now, but WISE will probably use the WISE UI still, but it will store the configuration in Elasticsearch or OpenSearch. And so as you want to add different WISE sources or configure, the WISE files manually, there will be no quote unquote manually. Instead, you'll go into the WISE UI and use that to configure it, and all of the configuration will be stored essentially in Elasticsearch.
That's a great idea.
You can also do that for capture and viewer already. Most people don't know this, but Arkime 5 and above allow you to have config.ini in Elasticsearch or any URL for that matter, and it will pull it down when it starts up.
That's cool. I don't think I realized that. That's interesting. I'll have to think about that. That might simplify a few things we're doing.
Yeah.
Now, if we could just come up with some means of thumbprinting the box that the daemon set runs on and use that as a node name or something as a unique identifier.
Yeah. So Brandon, I don't know if you can show your screen again, but right now what we're doing is the node name is just the node name of, I'll get this wrong, of the node. Is that right? And then the IP, the host name is actually the IP. So
Yeah.
to get around the way the viewers talk to each other is we're actually using the IP as the host name, which I think would have to change if we use your service map stuff, right?
No, not necessarily, actually. So the service mesh just basically ends up creating a proxy tunnel between source and destination.
Yeah,
As long as it knows where it's supposed to go, it should be fine.
Yeah, so right now we're doing right there the pod IP and the node name. For some reason, I thought when you're doing the service mesh, the IP would be different, but maybe I got
No.
Okay.
It just basically hooks into it and grabs traffic right before it leaves into the CNI, and then it hits a Nginx. That's it. It just hits an Nginx reverse proxy, and based upon your configurations, it'll encrypt the traffic, or it'll also use the certs for authorization, not just the encryption.
Okay.
So in theory, it should be seamless.
Yeah.
In theory.
Yeah, I think with host networking, I'm not. I guess it would work the same way. The service mesh would just bind to the host network adapter. I don't know. We'll have to test it and see. Are you using Envoy?
I am currently using no service meshes.
Oh, okay.
I would love to move that direction, but I'd probably use Envoy.
Okay.
It just depends on who's further along. I mean, Envoy uses Istio, and I don't know. I'd probably end up using Envoy.
Okay, we can test it with one and see.
Cool. Any other questions? Otherwise, I have another topic I want to ask about.